Engineering mechanics and law of forces. Engineering mechanics. Engineering mechanics is the subject which uses mathematics and science application in engineering practice. It is core subject of all engineering branches. It is useful for civil engineer, mechanical engineer, automobile engineer, electrical engineer, and other branch of engineering. Engineering mechanics is used for analyzing beam, truss, lifting machine, pulley screw jack, etc. Division of engineering mechanics.
Engineering mechanics can be divided into two parts, statics and dynamics. Dynamic has two parts, kinetics and kinematics.
Statics. Statics is the branch of engineering mechanics which deals with the forces and its effects on a body which is rest or in equilibrium under the action of forces. Dynamics. Dynamics is the branch of engineering mechanics which deals with the force and its effects on body which is in motion under the action of force system. Kinetics. It is the branch of dynamics of engineering mechanics which deals with the motion of bodies and about the effects of forces causing motion. Kinematics. It is the branch of dynamics of engineering mechanics which deals with the motion of bodies without considering forces causing motion. Rigid body. A body which does not deform under the application of forces is called rigid body. In practical life, nobody is perfectly rigid. But for simplicity in engineering mechanics, all body are considered as rigid body under the action of forces. Scalar quantities. The quantities which have magnitude only are called scalar quantities, such as length, mass, time, distance, volume, density, temperature, speeds, etc. Vector quantities. The physical quantity which have magnitude and direction both are called as vector quantity. Example: force, velocity, acceleration, moment. Representation of vector. A vector is represented by a directed line as shown in figure. It may be noted that the length OA represents the magnitude of the vector. OA rightward arrow represents direction of the vector. It is from O, i.e., starting point, to A, i.e., end point. It is also known as vector P. O is point of application. It is horizontal. It is pole. Unit vector. A vector, whose magnitude is unity, is known as unit vector. Equal vectors. The vectors, which are parallel to each other and have same direction, i.e., same sense, and equal magnitude, are known as equal vectors. Like vectors. The vectors, which are parallel to each other and have same sense but unequal magnitude, are known as like vectors. Addition of vectors. Consider two vector P and Q which is to be added. P and Q are coplanar forces. Take any point A, draw a line of parallel to P of length as per the magnitude of P. From B draw a line BC parallel to Q of length as P, the magnitude of Q in the same scale as of P. Join AC. Length of AC give the magnitude and direction of sum of P and Q. This is called addition of vector or law of triangle of forces. If more than two forces are to be added, it is done in the same way as above. The closing side of the polygon gives the magnitude and direction of the resultant of the force system. Length and direction of AE indicates the magnitude and direction of the force system adding all the forces. This is known as law of polygon of forces. Subtraction of vectors. Consider two vector P and Q. Q is to be subtracted from the P. P and Q are coplanar forces. Take any point A, draw a line of parallel to P of length as per the magnitude of P. From B draw a line BC parallel to Q of length as PE, the magnitude of Q in the opposite direction of Q in same scale as of P. Join AC. Length of AC give the magnitude and direction of subtraction of Q from P. In this system of units, the fundamental units are meter, m, kilogram, kg, and second, s. The following derived units will be used in this book.
Density kg per cubic meter, force in Newton, pressure in Newton per square mm, work done in Newton meter, power in watts, joules per second. The following standard
The following are standard abbreviations, which are internationally recognized. We shall use m for meter or meters, km for kilometer or kilometers, kg for kilogram or kilograms, t for ton or tons, s for second or seconds, min for minute or minutes, n for newton or newtons, nm for newton times meters, i.e., work done, knm for kilonewton times meters, rad for radian or radians, rev for revolution or revolutions,